Okay, so let's go through this two-body problem, right? Then they say that object A and B are stacked on top of each other. So given that the masses of A and B are 3 kg and 2 kg respectively, what is the horizontal acceleration of your object A? Where object B is being put by a horizontal force of about 10 Newton, right? And they already say one thing very important, which that assume all surfaces are frictionless. So how do we actually do this? Very simple. First, they say that all surfaces are frictionless, right? Means that the surface between A and B actually are frictionless. Meaning that if I use a 10 Newton force pull the box B, right, box A shouldn't follow. Box A will just drop off. So for example, after I pull, right, object B will be right here. So I pull with a 10 Newton force. But object A will just slide off, meaning that object A is right here. So it means that object A shouldn't have any acceleration. Yeah, because of the so-called assumption that they actually make. So they really say, oh, all surfaces are frictionless. Yeah, so normally for this type of question, they will set in another manner. So for example, right, they will say, what is the friction force that is exerting on box A and B? So how do we actually do this if let's just say we encounter this question? So for example, okay, so let's maybe do this question together. So let's just say, I got B, I got A. So this is 3 kg, this is 2 kg, right? Then they say, so assuming that got friction between A and B. Of course, for the table surface and object B, there's no friction to make things simple. So your object B is 10 Newton. Yeah, so in order for object A to actually move together with A, right? Move together with B, you must ensure one thing is that there must be a friction force acting on A between the surface of A and B. Okay, so now let's determine remember the few steps to do the two-body problem, right? First step, combine them together. So means that you will get 5 kg, right? A total of 5 kg. And of course, the force is 10 Newton. So obviously, I use second step, F equal to ma, right? So F equal to ma. So this will be your 10 Newton. This will be a total mass of 5. And of course, the acceleration is about 2 meter per second square. So this is the second step. Okay, third step, we turn back the clock. Okay, when we turn back the clock, we must go back to object A. Meaning that, object A is on top. So this object A is actually also moving at 2 meter per second square. Because everything must be moving at 2 meter per second square. So that they are moving together, right? Okay, so object A have a force, right? Has a friction force towards the right hand side. So how do I determine what is the friction, the so-called friction force, right? So I simply just use F equal to ma again. So my A I know is 2. So it's my M. My M is 3. So of course the resultant force is 3 times 2, 6 Newton. 6 Newton, right? So there's the only force that is acting on object A in the horizontal direction is the frictional force. It's the friction force. Meaning that this friction force, right, is 6 Newton. Yeah, so if I tweak the question a little bit, if they test for friction force, that is how you solve. But for the question that you send me, right, that one is assuming that everything is frictionless. So that's why A shouldn't be moving along. So A, the acceleration should be 0 meter per second square.